Concept number 4, introduce a new symbol. So I will just introduce you the symbol first. The symbol to translate is like this, is an element of. So this one is translated to this symbol. So this symbol looks like a letter C, and then there's a horizontal line across. Okay, please don't write it like this, because later on this becomes a universal set. So this symbol represents these 5 words. So X is an element of A, or sometimes we will say that it belongs to A. But most of the time we will translate this symbol into the 5 word is an element of. Okay, so please take note of the writing. So if X is not an element, okay, the simple one will be writing it as a dash over. You cross out. So if you cross out, that means it's not an element. Okay. So I'm going to show you a basic idea. I'm also going to show you the base. There's one confusion with this symbol. So if you look at example 7, we got a set A. Set A is 1, 3, 4, 6, 9, 10. So if we recap how many elements just now? So, okay, let's just do a quick recap. So there will be 6 elements. So 1 is an element of A. Okay, is it true? Yes, it's true. You actually find the 1 inside the set. So to translate, it will be 1 is an element of A. 6 is an element because you also found 6 inside. Okay, so 6 is an element of A. Okay, 8 is not an element because there's no 8 inside the set. So that's how I'm going to express it. Okay, so sometimes they will ask you for a true or false statement. Okay, so sometimes they will ask you for a true or false statement. Okay, so I'm going to show you a common mistake, or some students didn't realize that there is a difference. Okay, so sometimes they will ask you, which statement is true? So some students don't see a difference between these two. Okay, so this is true, and then this is false. Okay, so why is that so? Okay, this one is an element. But if the element comes with a curly bracket, this is not an element anymore. This is a set. And this symbol is an element. This symbol is used to describe element. This symbol is not used to describe a set. So there's actually a difference between these two. So if I give a curly bracket to a element, it is a set. If an element comes with no curly bracket, then that's just a pure element. So the symbol must match the description. So this symbol is meant to describe element. So you must know which is an element and which is a set. So that's one of the some confusion that you will see. Okay, so concept number 5. Concept number 5 is actually quite easy, but sometimes there will be some confusion as well. So we can have 2 equal sets if, let's say, they got exactly the same elements. So you can visualize the 2 equal sets like identical twins. So all the elements must match. So if the 2 sets are equal, then we are just going to be using the equal symbol. If the 2 sets are not equal, then we're going to be using the not equal symbol. It's as simple as that. But the condition for equal sets must be all the elements are exactly the same. So of course, the quantity of the elements is also the same. Okay, but one thing, the order of the element doesn't matter. Okay, so the order doesn't matter. So what do I mean by the order doesn't matter? So if you look at example 8, so if you look at set A is 1, 2, 3, 4. Set B is 4, 1, 2, 3. So they got the same element, but the way I arrange them in the curly bracket is different. It doesn't matter. They are still the same. They are still having the same element. Okay, so the conclusion is the two of them are still equal. So in example 9, C is the letters in paper. So if you're going to list out the letter, do not repeat. You do not repeat same element. So in this case, right, if you got two P's, when you list element, you don't need to list twice. They are the same. So it should be P-A-E-R. And in D, right, we're going to list out the words, the letters in pair. P-E-A-R. You realize that they got the same numbers of elements and all the elements are the same. Okay, so in this case, right, my conclusion is C is equal to D. So these two sets are equal because they got exactly the same element. So when you list element, you do not repeat the same element. Okay, so no matter how many times it's repeat. So if let's say in a long words, let's say S means like Mississippi, S is repeated a lot of times, it's still considered one element. Okay, so sometimes, right, in this concept, you will be asked to solve some equation. So for example, E is the element X, where X fulfill this equation. So if you look at set E, it is X, the elements is X, and the elements must fulfill this equation. So to fulfill this equation is quite easy. Am I right? So you think about it. So X minus 1 is 2. So X is equal to 1. So from here, okay, I should actually do the working here. So this, oh, sorry, I make a careless mistake. It should be equal to 3. So this is the elements of E. So there's only one answer that satisfies the equation. So there's only one element. So if you do out the next equation, so the next equation, you can choose to factorize. So here you got two answers. So F will have two elements. So obviously they are not equal. Okay, because it's like you see F got two elements and then E only got one element. So my conclusion is E is not equal to F. So I'm also going to take the chance to introduce you the idea of a subset. So if I'm going to draw this in a Venn diagram, it actually looks like this, huh? So I will draw the bigger set. So inside the set F, I got two elements, 3 and minus 3. And then, right, this is a E. So E is inside F. So E is inside F. So in a way, right, there's also another relationship. So E is a subset. So later on, there is a concept that relates to subset. So here it is a proper subset. So later on, I'll explain why it's called a proper subset. But anyway, for subset to happen, or what is your idea in your head about subset, you should think of a smaller set in a bigger set. So if it's a smaller set in a bigger set, that is considered a subset. So that is called a proper subset. Okay, so anyway, later on, we'll introduce a symbol on this. But right now, you just have the idea that a small set in a big set will be a proper subset. Okay, so in some real life thing, there is also some proper subset. Like, for example, okay, like, so you got a group of students who take mother tongue. So that is like a standard mother tongue. But out of this group of students, right, there is a small group that take higher mother tongue. So the students taking higher mother tongue is a small group out of the bigger group of those who take mother tongue. Okay, so that is called an idea of a subset. Okay, so in this part, right, you need to understand the idea of equal and the idea of using the symbol is an element of. Okay, so this will be the few basic things first.